let's go over the study guide for test 3. And actually, before we go through this, I want to point out it's very common for people to assume that test 3 is a comprehensive test because it's during finals week, but it's not a comprehensive test. It's just on chapters 20, 21, 22. So it's just like a regular test, 20 questions, just covering those 3 chapters. Nothing to freak out about. So let's match the terms up with their definitions. A molecule that is made from 2 monosaccharides, that will be a disaccharide. A connection between any 2 nucleotides in a nucleic acid, that would be either an amide bond or a peptide bond. Oh no, I was thinking of proteins. That's a phosphodiester linkage. Phosphodiester linkage. A monosaccharide with a carbon-oxygen double bond at the end of the carbon chain, that's going to be an aldose, an aldehyde sugar. An interaction between 2 cysteine amino acids, that is the disulfide bridge or a disulfide bond. 2 or more amino acids connected by a peptide bond. That would be a peptide. 2 or more amino acids would be a peptide. And we don't call it a protein until we have a whole bunch. What carries amino acids to the ribosomes? That's tRNA, so that's number 6. A molecule in which every carbon has either an OH group or a carbon-oxygen double bond, that's a carbohydrate. The relationship between adenine and thymine, or between guanine and cytosine, they are complementary base pairs. The cyclic representation of a monosaccharide, the Haworth structure, that's number 9. The sequence of amino acids in a peptide, that is called the primary structure. Number 10. The pH at which an amino acid exists as its zwitterion is the pI. General class of molecules that includes monosaccharides, disaccharides, and polysaccharides, that's carbohydrates, which I've already used. Better fix that. So carbohydrates is number 12. We'll come back to number 7. 13, secondary structure of a protein that has a folded shape. That is the beta pleated sheet. An interaction between nonpolar amino acids that contributes to the tertiary structure. So interaction between nonpolar, that is our hydrophobic interactions. Nonpolar, doesn't like water. Nucleic acid that transmits genetic information within an organism to control cellular function, that is RNA. 15 is RNA. 2 or more tertiary structures of a protein held together is our quaternary structures. That's number 16. A peptide with at least 40 amino acids, that will be our proteins. 17. Type of RNA that forms ribosomes is rRNA. A monosaccharide with carbon-oxygen double bond on the second carbon chain is the ketose. RNA that carries instructions for protein synthesis is mRNA. An interaction between polar amino acids that contributes to the tertiary structure. Polar amino acids, they are going to be having hydrophilic interactions. 21 is hydrophilic. Protein structure caused by hydrogen bonding between the nitrogen and hydrogen of one amino acid and the carbon-oxygen of another. That is our secondary structure. The assembling of amino acids to make a protein. Ooh, that's transcription versus translation. We'll save that one. A set of 3 nucleotides that codes for an amino acid is a codon. 24 is codon. Secondary structure of a protein that has a twisted shape is the alpha helix. A molecule made from 3 or more monosaccharides is a polysaccharide. 26. The building block of proteins are amino acids. Small molecules that join together to make DNA and RNA are nucleotides. Protein structure caused by interactions between the R groups of the amino acids, that's the tertiary structure. The synthesis of mRNA, so that's the transcription versus translation again. So transcription versus translation. Translation is when we take one language like English and we turn it into another language like Spanish. Transcription is when we are working within the same language. So that would be like spoken Spanish being transcribed into written Spanish, but it's all staying within the same language. So the way that I remember transcription versus translation is that when we are staying with nucleic acids, so DNA to DNA or DNA to RNA or something like that, that's going to be a transcription. But when we are translating nucleic acids into proteins, amino acids, things like that, that is translation. So the synthesis of mRNA from DNA is just a transcription. And then where was our translation one? Lost it. We'll find it. General class of molecules that includes DNA and RNA, those are nucleic acids, 31. Protein that speeds up the rate of a biological reaction is an enzyme, so that's 32. Nucleic acid that transmits genetic information from parent to offspring is DNA, 33. The location of protein synthesis, the ribosome, 34. The amino acid that's ionized with a positive and negative charge is the Zwitter ion. A molecule that assists enzymes is the coenzyme, 36. So what did we leave out? The molecule that I originally classified as carbohydrate is a monosaccharide. And then the assembling of amino acids to make a protein, that's where we're converting RNA into the proteins.